For our next Fireside Chat titled Lessons Learned from the U.S.-China Tech Competition, please welcome to the stage Luke Murry, Head of Government Affairs at Marvell Technology, and Dr. Nadia Schadlow, Advisor on SCSP's Board of Advisors. The conversation will be moderated by Eliot Chen, staff writer at The Wire China.
Good morning. Thank you very much, everyone, for joining us for the last session of this morning before we head to lunch. My name is Eliot Chen. I'm a staff writer with The Wire China. We're a New York-based business magazine. We cover US-China relations, Chinese politics, and Chinese business. With me today, on my far left, is Luke Murry, Head of Government Affairs at Marvell, a global semiconductor firm based in California. From 2017 to 2021, he served as the then minority leader, Kevin McCarthy's national security advisor, advising the leader and helping to shape Republican positions on foreign policy and defense issues. Next to me is Dr. Nadia Schadlow. She is a senior fellow at the Hudson Institute, where her research focuses on issues related to defense mobilization, advanced manufacturing, semiconductors, critical minerals, and energetic materials. Previously, Dr. Schadlow served as the Deputy National Security Advisor for Strategy, where she was the architect of the 2017 National Security Strategy, focusing especially on great power issues. So earlier this morning, we explored the current state of the US and China's fusion buildouts, examining the systemic strengths and weaknesses of each country's ecosystems. In this session, we'll shift our focus to the strategic level, looking at, in particular, what concrete actions the US government should take to ensure that America maintains its leadership in fusion science as we move from research and development towards the commercialization of fusion energy. So we'll start with the first question for both of you, so feel free to jump in whenever you want. We heard right at the start this morning from the Secretary of Energy, who has said many times before that he sees fusion energy as a key national priority. In SCSP's latest report, Fusion Forward, published last week, one of the report's recommendations is to have the White House issue an executive order. Why is that important in technologies like fusion for the highest level of government to set that kind of policy demand signal?
Well, I think it's very, very important, especially in fusion, right? Fusion, other than this audience, you can test it out, but most Americans, probably when you say fusion needs to be a national priority, they'll say, what? Or they'll think, nuclear fission. So setting it out in a clear way, explaining to the American public what fusion is, how important it is, and then getting the executive branch to consider the follow-up measures you need, which we'll talk about on the panel, I think is exceptionally important, especially in a relatively new domain like this.
Yeah, and I would just add that, obviously the federal government is a massive bureaucracy. Department of Energy is 15,000 employees alone, and if we're really going to achieve the objectives laid out in our report, it's got to be an interagency effort. So it's not just Department of Energy, it's Commerce, it's DOD, it's all sorts of different agencies, State Department. And if you're going to coordinate across agencies, you really need that prioritization. It's not so much that a government bureaucrat or a civil servant is going to work in opposition to these goals laid out. It's just they have so many other priorities that they're supposed to also work on. And how do you make sure that fusion really stays, if not at the top of their list, then at least near the top of their list? An executive order is the most powerful tool that a president has to effectuate any kind of policy that he makes. And if that's true, then if you issue an executive order and a bureaucrat doesn't prioritize it, there's going to be consequences for it. So at the highest level, it gives folks the authority they need to prioritize and make sure others prioritize fusion.
And it can sometimes substitute when a formal strategy of sorts doesn't exist. An executive order, in essence, captures the objectives where you're driving toward and then the steps you need to take.
It strikes me that a lot of the technologies that we increasingly are talking about in the domain of US-China competition, and frankly, a lot of the ones that SCSP looks at in a lot of detail, are technologies from fusion to semiconductors, AI, quantum. These are technologies that are almost converging. And maybe we can talk about what does it mean for that convergence? What does it mean for US national security planning? And how does the government need to be organized to compete effectively and sort of adapt to that reality?
Well, I mean, this is an audience that knows, and the previous panel also mentioned this. They're intertwined technologies, right? There's a ripple effect in one area and the other. They're all connected: AI, quantum, semiconductors, especially fusion, to power a lot of these technologies. So we need to think simultaneously. So while as strategists we often talk about prioritizing and recognize that, in some senses too, we need to succeed in all of these technologies across the board simultaneously. That's not easy for government to do, but it's critical. We need government to essentially create the landscape to reduce the obstacles to success in many of these areas. We have the brilliant scientists, we have the scientific breakthroughs, we have the innovation, but government needs to create the landscape to allow these innovations to flourish and to scale, and in many senses, as we'll discuss, to deregulate, to remove the obstacles to growth.
Yeah, if you just spell that out, like what does it mean for critical technology areas to find real meaningful convergence? Well, at least one aspect to that, one answer to that question is that the development of one technology depends on the development of the other technology. So if you're going to win the quantum race, you better have very advanced chips. If you're going to win the fusion race, you better use AI to speed things up, as we just heard on an earlier panel. And you can go down the list on critical technologies areas on how they depend on the speed of one another. So from a US government perspective, both the executive branch and the legislative branch, you can't just focus on one technology area. Now, not everything can be a critical technology area, and we need to be prudent in what we label a critical technology area, but you can't just fund quantum, particularly basic and applied research for quantum, and not go after robotics, or not go after advanced microelectronics. So there is just a very clear reality here that the kind of funding that we're talking about in critical technology areas probably needs to be pretty robust. And that needs to, actually the administration has already issued some policies about realigning funding around these critical technology areas. I think that's a great first step. Second step is Congress needs to properly fund it, authorize it, and appropriate it. And then as you work on implementation, right, it's one thing to have an executive order which lays out the policy. It's another thing to fund it. Then you've got to implement it. And I really think some sort of interagency body, maybe a cross-agency technology council within the executive branch, where you have principals or their deputies, they're regularly convening together to talk about the progress on these relative technology areas and identify where are the obstacles, where are the bottlenecks, what questions do we need to answer sooner rather than later. Because when you're working interagency, the most challenging thing on an interagency effort is communication. You don't know what one agency knows and vice versa. And so and sometimes those are the easiest problems to solve. If you just expose them and you get the right level of senior officials to know about them, they can pull the trigger and get action done.
It strikes me that this conversation about the US and China competing on fusion, there are patterns that we're seeing in the competition on fusion that we've seen, quite frankly, before. I think one thing that I really liked that was mentioned at the panel earlier this morning was, they were talking about this TikTok video that had been uploaded in China showing just the sheer pace that some of these fusion facilities are being built in China. And I think David mentioned, quite simply, they're welding at night. That sticks with me because, one, it's a striking image, and two, it's just an illustration of the pace that China can build at that is just immensely difficult to compete with, right? So I was thinking maybe we could zoom out a little bit and think about, how do some of the findings that you've come across through the work of the Fusion Commission, how do they transfer to other strategic technology sectors. What are some of the broader strategic lessons that you've learned about the American innovation ecosystem beyond fusion that we can think about here?
Yeah, there's a couple ways that I've thought about this since serving on the commission. One is there is a difference between inventing the technology and putting it to use. Innovation and application. And if, we just had a panel on AI. AI is a great example. We continue to lead the world on technical breakthroughs on AI. And yet, if you look at application throughout the economic sector, China's already way ahead of us. And if you go over the past 75 years, we used to do both really well. So think about the semiconductor industry. We were the first to invent the transistor, and we had the biggest chip companies in the world. Think about the internet. Invented the internet, and we had the biggest internet companies in the world. So you have both at R&D and at commercialization, productization, we were leading the world. We still lead the world when it comes to fusion on R&D, and we still have the biggest companies in terms of private investment in the United States. But I'm really concerned about how China is setting itself up in being able to scale fusion technology once those technical breakthroughs are achieved.
Mm-hmm. Yeah, I think we've learned that there are many lessons in the past where we've lost. Innovation is not enough, right? So the next decade, the next 2 decades going forward, words like scale, speed, replicability, commercialization, all of those are critical. The innovation itself is not enough. And I think now this is where government can play a big role in all of those areas. Government needs to ask itself, to what degree can we help in those domains? It's about deployment now.
Mm-hmm. Mm-hmm.
And we've seen how we've lost out in other sectors, right? I mean, renewables was a big issue, maybe previous administration, but the lack of, where China has led in renewables, led in battery production, critical minerals, mining, all the inputs and components. Mm-hmm. So innovation is not enough.
Can I just add one on the policy side? I went to a conference recently, and there was a professor up, and he talked about some leading indicators that he watches in his space. One is the number of graduates in the appropriate fields. Obviously, China is beating us on that. And 2 is the papers that get published and presented at conferences. He said in his area of research a few years ago, it was basically US and China, and US basically had the lead in terms of the papers being presented. The last couple years, China has dominated. And the last conference he went to was 30 papers presented by Chinese professors and 1 by an American professor. So if that's a leading indicator of who is going to be advanced or leading the world in the next 5 to 10 years, that's a real problem. So what do you do about that? One, again, you go back to R&D dollars, right? Like, the fact of the matter is university professors need money to do their work and publish their papers. That's, yes, federal government, but that's also philanthropy. That can also be the private sector can chip in there. The second kind of policy prescription is when you think about the race against China and how quickly they're developing on these leading indicators, you want to make sure that you're giving the private sector as much room to run as possible. And the R&D tax credit is terrible. We are 36 out of 38 OECD countries when it comes to our R&D tax credit. China has a 220% R&D tax credit, which means every $100 that a Chinese company invests in R&D, they can take a $220 tax credit. Comparably for the US, American company invests $100, they get $10 tax credit. So that is both on the basic and applied research funding. That's a role that the government has always played historically. And on the tax credit side, that's how we, in our system, spur innovation. We need to get a lot more competitive to spur on innovation.
On the topic of tax credits, Luke, maybe we can stick with you. What would it look like in practical terms to make fusion a national priority from the perspective of Congress? What can the legislative branch do to really assist and get fusion going in the US?
Yeah, it plays a critical role. And actually, if Congress doesn't step up to the plate, I'm very, very concerned about our ability to achieve these goals that we've laid out. Number 1 is funding. Our report calls for $10 billion. That's going to go to key milestone programs the Department of Energy can run for companies reaching milestones. They get X amount of incentives. I think also just as important are the R&D test facilities to get those technological breakthroughs that are still needed on fusion and building those up, funding those, staffing those, et cetera. And Congress, at the end of the day, is the one that can appropriate that, right? And if you look at the return on investment, if we lead the world in fusion, if we not only achieve the technological breakthroughs that are necessary, but then we actually have the international regulatory frameworks where we can sell fusion energy abroad and be the world leader, it's going to be a massive influx to our economy, and we're more than going to get our money back in that sense. Second way that Congress is really important is political support. So if DOE, if the president does provide authority for a fusion lead, you really need one person. We talked about bureaucrats and all the different priorities. We need one person whose sole priority it is to develop or to achieve these objectives that we've laid out. And that's all they work on every day, all day. It would be great if Congress could authorize that position and fund that position. And that executive order should give that position the relevant authority needed so that position can be effective. Also, political support can be really helpful when you're talking about the administration making the kind of departmental changes and interagency councils and task force and those kinds of things that it's setting up. If Congress lends its political support via letters from relevant chairman, ranking member, Senate Committee on Energy and Natural Resources, or on the House side, Energy and Commerce Committee, and say, yeah, we support establishing a fusion league. Yes, we support establishing an interagency task force or council. Obviously, the administration and executive branch is not afraid to do something that Congress doesn't appreciate, but when the executive branch is thinking about taking bold action, like we call for in these recommendations, and they know they're not going to face a firing squad from Congress, but actually, a welcome reception from Congress, that's going to speed up administration action and incentivize bureaucrats who might otherwise be a little bit gun-shy because they're not sure they might be hauled before X committee to explain why they're doing what they're doing. So that's funding, that's political support, and then oversight. It's one thing to have an executive order. It's another thing to have a national strategy, which I haven't talked about too much, but it's super important in terms of implementation, figuring out who does what. And if you don't have implementation, it doesn't matter how good your policy is, it's not going to be effective. And Congress doesn't have to be an overlord in that sense, but it is helpful for staffers to email their counterparts in agencies to ask for updates, to get informal briefings, to call hearings, to make sure that implementation is proceeding at pace and you have that proper incentive for the executive branch to keep working this. And then finally, this is going to be an effort that extends beyond this president's term, right? I think key progress and milestones can be reached, but full commercialization is going to take more than this term. And whatever executive order, obviously, that this president issues, the next president can issue one completely opposite or can just deprioritize it. Congress should think about codifying what the administration is doing, or hopefully will do, and in that way, it can last beyond just this term.
Yeah, so as Luke pointed out, the executive branch can set a signal as we started the conversation in terms of an executive order establishing a national fusion lead. And in doing so, it helps to de-risk an environment, it helps to attract money and capital to an environment, and it can drive deregulation. So if there's one word throughout the report that's used, it's expedite. The executive branch can drive expedited licensing, right, for fusion. That's critically important. We can't use an approach that uses bespoke licensing for every fusion generator. There's something called a design-specific license that's out there, and it's an idea that the executive branch can help to push in a deregulatory mindset to say we're establishing a landscape to allow fast deployment and commercialization. Expedite comes in terms of environmental permitting, also critical at the federal and state level. That can and must be expedited to allow, again, for the commercialization and deployment at the scale that we need. Expedite, again, comes in with looking at our electrical grid and the need to expedite permitting, but also driving changes in that domain. It's a hugely complicated domain, but it can't take 6 years to attach a fusion generator to the grid. It can't. It absolutely, the grid has to catch up. And we're seeing in so many of these areas, to go back to the technologies you mentioned, where you have the fast-moving pace of all of these technologies running up against these calcified infrastructures, essentially. And it's consistent across a range of areas. And finally, the federal government and the executive branch can and must play a really important role in global alignment. That's something that's clearly within the hands of our State Department, Defense Department. We need to make sure that external organizations, international organizations that can shape that regulatory environment, which then will shape the ability of American companies to deploy and lead globally. That matters. China just hosted a conference with the IAE on fusion. We need to be hosting conferences here. We need to talk to the IAE, get a US ambassador in there to make sure that we're leading in these global conversations, because it impacts American businesses and provides the opportunities. We can't afford to lose out. And in addition, the global angle is kind of interesting too, because it helps the US with scale as well, right? It provides us with external markets as well, which is just as important for American companies. We need to do both simultaneously. So in all of those areas, the executive branch, plays a key role.
One thing that really struck me when sort of looking at what China is doing on fusion development is, I think earlier this year they developed this consortium, which brings together not only sort of China's fusion companies, but all of the infrastructure providers that are necessary to go and build it, right? That's the steel companies, the people in the aerospace industry, because as it turns out, there's a lot of technology that transfers over. And that's just a strength that you have, I guess, with the central government, right? The ability to pull together various state-owned enterprises and bring them all into the same room. Is the US government, whether the executive branch, the legislative, or through something like the commission, do you see a sort of role for them in sort of that convening power, bringing them together and sort of getting everyone in the same room?
Yeah, I mean, absolutely. I mean, it's not as easy for us to create the same type of geographically kind of concentrated ecosystems, right? We have states that should be competing with each other in this country, and that can make things more innovative. But the competition should be about how can we attract fusion generators and manufacturing facilities to our state most quickly. I think that's a good type of competition that we want to increase. But overall, the setting forth the foundation for manufacturing for fusion, understanding the importance of those supply chains, working with Congress on credits like 45X and different credits to pull in manufacturing and ensure that we're not losing that supply chain down the line. And we're already at risk, right? We're vulnerable in key parts of the fusion supply chain already, whether it's semiconductors, high voltage capacitors. We all know now everyone's critical minerals, lithium, gallium, silicon carbide, components that go into what you need to create fusion. We're already vulnerable. So the federal government can play a big role in ensuring that manufacturing sector is more robust than what we've seen in other sectors today, to go back to the areas we've lost.
Yeah, and I would say in addition to convening, the government has a special ability to collect information.
Yeah,
and particularly on the global supply chain when it comes to fusion and what we're going to need to scale, we still have too many dark corners. We don't know if there's gaps, or maybe there's dependencies that are not in our interest or could slow us down. This is where obviously I think having a lot of international allies can be really helpful, but we really need a better map of the global supply chain. Department of Commerce does that kind of thing. It's done it on other industries. It can do it on fusion. I think that's a key role. And then kind of back to an earlier question in terms of what are some of the challenges that we see with fusion that then you also see with other technology areas. I think what surprised me on this commission is it's not all about technical breakthroughs and scientific breakthroughs. Yes, there are challenges there, and yes, we have a spectrum of confidence in our ability to achieve those in the next 5 years or 10 years or what have you. But it's not just about that grant money to get that technical breakthrough. You also need the Nuclear Regulatory Commission to provide permitting and licensing. You need the Commerce Department to set up proper export controls or lack thereof. And you need Department of Energy to be running these grant programs. You need State Department to set up the international regulatory framework. You need DoD to weigh in on what's sensitive to national security, what's not. And that's true in fusion, that's true in AI, that's true in quantum. There's an interagency challenge there where, yes, the government has this inherent ability to convene people and bring them together, and it should use that. But also that interagency challenge really is massive, and we have to sort that out because it won't just affect fusion, it's also going to affect these other critical technology areas too. And then lastly, We can't wait till we get the scientific and technical breakthroughs to then give the licenses and the permits and worry about supply chain, because then we'll lose the race on fusion. That all has to be in place or actually ongoing before those breakthroughs to make sure that when we do achieve those breakthroughs, there's no significant delay and we can really scale.
Right, to go back to the point of simultaneity, right? It has to be done simultaneously. And I think the executive branch can also play a role in setting forth metrics, time-based metrics. You know, in government, no one really likes to sort of admit how long something takes. They certainly don't like to project that. The executive branch can actually hold agencies accountable using time-based metrics to understand, you know, something that takes 6 years shouldn't. 3 months, 4 months, 5 months. But once you start to do that, you kind of create accountability that makes everyone a little bit uncomfortable.
Sure.
But it could be, you know, it's really important in this domain.
Luke, Nadia, it's been a pleasure. Thank you very much for sharing these insights with everybody. Please join me in thanking each of our panelists for being here today.